Is it?
Yeah, now it's visible.
Suitable.
So today, as I said that I want to explain how KNN works and how to implement it with scikit-learn. So here my problem is I want to classify whether a particular patient is diabetic or not, given that the age of the patient and the insulin level of the patient. So I can formulate this problem as the as a formula like the dataset has two types of data. One is xi and one is yi. So here xi is input. Input means, as I said, age and insulin level, and yi is the output, means whether the patient is diabetic or not. So yi can be 0 or 1. So 0 mean non-diabetic and 1 mean diabetic, and xi is the real value. So because age and the insulin level is a number, so it is real value. And as the class is two types, one is 0 and 1, diabetic or non-diabetic, that is why it is binary classification. So and one more thing, k nearest neighbor can also be used as classification as well as for regression. And what is the difference between classification and regression? uh, Here yi is belonging to a particular discrete value 0 or 1, that is why it is called classification. And if it is a real value, for example, if I want to predict the height of a patient, then it will be real value, because height can be any type of value, 165 centimeter, 165.7 centimeter. That is why it is called regression. So so to solve that problem using KNN, first I want to explain it with pictorially. So you can see that initial data is scattered like that, and the red points are diabetic and the green are non-diabetic. So suppose and x-axis is denoted the age of the patient, and y-axis is denoting the insulin level. So now if tomorrow a patient come to me and he is lying here, and I have to predict whether this patient has diabetes or not. So what k nearest neighbor is doing is, it will first calculate the nearest neighbors, the distance between the nearest neighbors. For example, if I take number of neighbors equal to 3, then it will first draw a circle, and then it will uh, as because k equal to 3, then it will take 3 neighbors, nearest neighbors, and it will calculate the distance, and it will take the majority vote. Majority vote means here the majority is class B or non-diabetic, so it will predict that the patient is non-diabetic. Now the question is how to calculate those distance. So in scikit-learn, there are three types of distance which are already implemented, and I want to explain that how it is calculated. So first one is the Euclidean distance. So Euclidean distance also can be called as L2 norm, and why it is called L2 norm, I will explain it. So L2, for example, this point is x. The coordinate of this point is x11 and x12, as I have mentioned. And suppose this point's coordinate are x21 and x22. The formula of the Euclidean distance is nothing but square root of x11 minus x21 whole square plus square root of x22 minus x12 whole square. This is for Euclidean distance. And one more thing is there, which is called Manhattan distance. It is nothing but the absolute value between x11 minus x21 plus x22 minus x12 for these 2 points. And Minkowski distance, which is called LP norm, and for that we can retain this formula like that. So the formula here is for 2 points x and y, I can write it summation of I equal to 1 to n xi minus yi to the power p whole to the power 1 by p. And the interesting part is that if I substitute p equal to 2, then it will give the Euclidean distance formula. So if I put p equal to 2, then it will be like summation of I equal to 1 to n xi minus yi to the power 2 square root square root. So it will give the Euclidean distance. If I put p equal to 1, then it will give this Manhattan distance. That is why it is called L2 norm, because p equal to 2 here, and that and if p equal to 1, then it will give the L1 norm. That is why it is called L1. And Minkowski distance is LP norm because it is denoted by p. So and these are the steps. So there are several algorithms. The first one is brute force. For brute force, there are, first step is it will find the k nearest points, and that it will take the majority votes. So for example, if the 2 points are plus and another is negative, then it will take plus. So it is better to take as k as odd number, so it will be good to measure the class. So now, as already Suraj mentioned about scikit-learn. So scikit-learn is a free software machine learning library which is used in Python programming language. And using a scikit-learn, you can use for classification, regression, and clustering algorithms, which is including support vector machine or SVD, random forest, gradient boosting, k-means, and dbscan. And the scikit-learn, if you see the underlying code of scikit-learn, you will see that the written in C, C++, and Python. And also scikit-learn integrates many Python libraries such as matplotlib, numpy, and pandas, scipy, etc. And this is the source code of scikit-learn. And for installing, you have to just run pip install -u scikit-learn. So now, as I have already discussed the how KNN works in brief. So in scikit-learn, there is a uh, module called sklearn.neighbors, and within that there is a function called kneighbors classifier. So it is doing the KNN classifier for you. So, and in this KNN classifier function, there are several arguments, and I will explain each and every arguments in brief in upcoming examples. So so first one is n neighbors equal to 5, and weights, algorithm, leaf size, p, metric, and n jobs. So let's go one by one. So first one is n neighbors. N neighbors, as I have already said, that n neighbors means k. So how many numbers of neighbors I want to see, or I want to calculate the distance. It is nothing but the value of k, as I have discussed in the previous example where k equal to 3. So you can put any of your choice, k equal to 1, 2, 3, 4, 5. It will be an integer. And second one is weights. So weights means you can also give some weightage to the neighbors. So if you write weights equal to uniform, then it will give the equally weight to the all neighbors. Or if you want to give the specific weights to different neighbor, then you can also do that. So here weights points, so here weights will be given in such a way that it will be the inverse of the distance. So it is intuitive that closer neighbors of a query point will have the greater influence than neighbors which are further away, because it will give the weights inverse to the distance. So if the distance is small, then it will have the highest weightage, like that. And algorithm, so in sklearn there are three types of algorithm are there. First one I have already discussed, which is brute force. So in brute force, what it will do is it first take the neighbors, and then it will take the majority votes. And for that, time complexity is order of n squared d, where n is the data points and d is the dimensions. And why n squared d? So if you see that here, first it will find the k nearest points, and then it will take the majority vote. And we and these two steps will be within a for loop, which is for k neighbors. So first, there are for each and every k. For example, I want to see that which k is the best for my model. So I want to see k equal to 1, 2, 3, 4, 5, 6, 7. So for each k we have to run these two steps. That is why it is you can say that, and for the distance calculation you have to calculate the distance from each and every point from the query point. So if there are n points, it is n, and if k is, in worst case it can be n also, k equal to n, so n into n, which is n square. And why d? Because the dimension of the d means, here I have used only two features, that is why it is d equal to 2. If it is greater than 2, then it will be that value. So here it is n square d. And also one and two more algorithm are there also, which is called KD tree and ball tree. So I want to explain those in very brief manner. So what KD tree does? So first, KD tree, what it will do is, suppose there are 1 2 3 4 5 6 7 8 9 10 10 points. So 10 points, first it will plot the 10 points in the xy plane, and then it will project each and every point on this x axis. So in brief, what it will do is, it will partition the whole xy plane in several partitions, and then it will see where the query point is belong to. So for that, first we have to plot these points into the xy plane, then project it on the x plane, and after that you have to calculate the mean. Suppose here the mean is 6. If you see that it is, if you calculate the all mean, then it will be 6. So you can write now the first step is, you have to partition the whole space into two part. One is the left side of this blue line, and the right side. So here you can see that in this binary tree, first condition is x1 greater than equal to 6. So x1 is your query point, so you can think of as a query point. So x1 greater than equal to 6, and then it will have, if yes, then it will go a left side, if no, then it will go right side. So if yes, then these points will be in left side. So you can see that 1923 1923 and 4137 and 41, and in right side these points will be there 6 8, like that. And in next step you have to alternate your axis. So first what you have done, you have just project these points into x axis. Now you have to project these points only, not these points, because already this point is partitioned in this rectangle. So now you have to project these points into this axis, and similarly you have to calculate this mean, and then you have to see that which points are less than or greater than. So you can see that these points will be greater than 4. I think 4 will be the mean, and these are the mm, in right side. So like that you have to create the binary tree, and you have to see where your query point. Suppose my query point is here. So now we have to uh, create a circle, and we have to see that which are the neighbors, and take the majority vote. And why it is very efficient is, uh, as I mentioned before in previous one, that we have to calculate the distance from each and every point. But in KD tree, if you partition that in such a way and you build this B tree, now your search space is reduced to only this part or this part. Suppose your point is belongs to like this point, so it will go only this part. So it will see that if x1 greater than equal to 6, so if it is that yes, so then it will go is this part, and it will not explore this part. So search space is now only this part. So here, and this is, and we all know that the height of the binary search is log n, so time complexity will be log n into d, because the dimension is d. And as here we have only have two dimensions, one is x, one is y. That is why it is called KD tree. And if it is more than two dimension for 4, 5, 6, then you can't separate the uh, plane with lines. Then you have to create or hyperplanes, then it will be called as ball tree. This is the difference, and the time complexity is the same. So in this weights I have discussed, and in algorithm you have you can put auto mean it will take the brute force, either or you can write brute or KD tree or ball tree. And leaf size is 30, and leaf size is needed when you use KD tree or ball tree, because to define by any tree you have to store the leaves. That is why leaf size is needed. And if you use just brute force, the first one, or auto, then leaf size is not needed. And one more thing, that each and every argument is not needed each and every time. So you can just write your own arguments which you want to change it. So next it is p equal to 2. P equal to 2, as I have said, that if you want to use L1 norm or L2 norm or Minkowski, so for Euclidean distance p equal to 2. If you want to use Manhattan distance, then it will be p equal to 1. And metric is Minkowski if you want to use. And n jobs is if you want to say this algorithm that you have 4 cores or 5 cores, and you want to do the job in parallel manner, then you can do that. Equal n underscore jobs equal to number of cores in your machine. So as I have said, leaf size is the int value, and default is 30. If you don't mention it, it will be taken automatically as 30. And leaf size is passed to ball tree or KD tree, and the memory required to store the tree, which I have already discussed. And p is int. P is all and p is also int, because p will be 1 and or 2, like that. Um so this is the parameters, and this is the scikit-learn. This is the k neighbors classifiers function and their arguments. And now I want to solve a problem. So here the problem is to predict whether the sorry.
So instead of brute force, I mean, in brute force we are measuring all the points, right?
Yes, yes.
So instead of that, we can just take the near, I mean, some domain near the our test point. I
Yes,
mean, we
yes,
can,
yes, yes, yes.
in
Yes,
that case it will be
actually,
much
this is
faster.
done for k equal to 1, 2. I am saying for worst case. Actually, if you want to calculate the time complexity, you have to calculate for the worst case. If k equal to 1, k equal to n, if k equal to n number of data points, then that is why I am saying that time complexity is n squared d. So
Yes, that is okay, but I'm just saying we can just restrict the domain of the space, like some like 25% of the data or
yes, yes,
something.
yes, yes. I'm going into that. I'm going into that. I'm just saying the how the algorithms is implementing in k-nearest neighbor. And now this, and in the way of this, to solve the problem, I will discuss how to split it in different sets and how to solve it. So you just so can I move forward?
Yes, sir.
Okay. So now my task is to predict whether the patient in the uh, and it is a dataset name, and then I just downloaded this dataset from Kaggle, and the dataset name is Pima Indians Diabetics dataset. And so to solve that, you have to import this scikit-learn function. You can see that numpy, pandas, matplotlib we have already seen. And for scikit-learn there are some extra like trends, test split, k nearest neighbor, accuracy score, cross validation score, like that. So first we have to load the data, and I have downloaded this data, and the data file name is diabetes.csv. CSV stands for comma separated value. So you just load it, print it, and if you print it, you will see that there are 8 features, and one is for outcome. So you can see that outcome is here, And in outcome, 1 means the patient is diabetic and 0 means non-diabetic. And there are eight features like age, BMI, insulin, skin thickness, and so on. So if you just print the shape of the data frame, you can print it like df.shape, and it will show the 768 cross 9. So here the number of rows in the data set is 768, and the 9 is the features. So the 9 is the number of columns. So within now 9 columns, 8 are the features and 1 is for class level. And next to just to actually to start with this, to solve the problem, first we have to create the arrays for train and test. So first what we have done is, from whole data set we drop this outcome for the to take the these eight features and their values, and in another array we have taken just this outcome, these classes 1010. So it is doing that x equal to df dot drop. Drop means just drop this column. So df dot drop, df this data frame name which I have here mentioned, this pt dot read csv. Drop which I want to drop outcome, x is equal to 1 means the column, and if you say 0 means row. So x is equal to 1 dot values. So I want to drop the values in outcome and then display it. And similarly for y, I want to see the outcome, and in y only the outcome will be there. So if I display it, you can see that in array, in this x, this first eight features and their values are there, and in array only 10 these numbers are there. So now I want to split the dataset into train and test. So for that, in sklearn there is a function called train underscore test underscore split. So I have to I have splitted it into two types. One is train and test. So train is x train and y train. Means in x train there will be eight features and their values, and in y train the only the class levels, which mean diabetic or not, 0 or 1. And similarly for x test and y test. So you can see that in train test split there are several arguments, and the most important one is the datas x and y. X and y are the arrays which I have here created first. Then test size is zero point 0.4, means test will be 40% and 60% will be train size. And random state and stratify, it is not mandatory, but you can write it. So random state, what it is doing is it actually control the shuffling, and stratify equal to yes means data is splitted uh, uh, using the class level. Means here the class level is the 0 1. So if you mention that I want to split the data according to your class levels, you can do that. If you write equal to y, then it will take the class level in which the data set is present. So in data set the class level is outcome, so it will just split it according to that. That is why it is doing. But random state and stratify is not mandatory. These three is mandatory: x, y, and test size. Next I want to observe the accuracies for different values of k. So as I said that I don't know that which k value will be the most suitable one. So I have to explore for different k values. For that I have imported this k nearest classifier. Then I have taken this k range equal to 1 to 9 minus 1. So 1 to 8. And so I have created this neighbors equal to np dot arrange 1 to 9. So it will iterate from 1 to 8, and then train accuracy equal to np dot empty len neighbors. So it will return, what it will do is it will return an array size of 8, and it will store the each k value and their accuracy. For suppose k equal to 1 will be for k equal to 1 how much accuracy is there. For k equal to 2 how much accuracy is there. So like that the array size will be 8, and each and every index will represent the accuracy for the particular k value, and test accuracy for all, and for test accuracy also we also want to create this array similarly. And now just we want to iterate for different values of I and k, and see that how much accuracy is given for train and test. So for that I have just written a for loop I k in enumerate neighbors. Neighbors means k equal to 1 to 8, and then I have called this k nearest classifier in bracket n neighbors equal to k. And here you can see that I have only mentioned that the neighbors and the k values, and other values which I have discussed earlier I didn't mention, and it is not mandatory. So here I want to use the value of k, that is why I have mentioned n underscore neighbors equal to k. Then feed the model. Feed model means you are training the model. So it is nothing but k dot fit training values x train comma y train. And then now you want to calculate the accuracy scores. So train accuracy and as I. So as I have said that the train accuracy is a array size of 8, and each and every index will return a accuracy score. For I equal to 1, I equal to 2, like that, I equal to 8. For each k value it will calculate the particular accuracy for train and similarly for test. So now I want to plot it, define k values and their accuracy. So if I plot it, you can see that the x-axis denotes the number of neighbors and y-axis is the accuracy. So and the objective to plot it to see that for which k value the train accuracy test accuracy is maximum. So you can see that for 7 the test accuracy is maximum, which is nearly 75%. So I can conclude that uh, I can take k equal to 7 to train my model. And for plotting, the code is I think straightforward. Plot title KNN varying, this is the title, and then uh, plot, it is matplotlib plot, and then neighbors test accuracy in one curve, and another is neighbors train accuracy, and then number of neighbors in x and accuracy in y. So now I just train our model using 7. As I have seen that k equal to 7 is the giving the maximum accuracy. That is why I have trained the model using k neighbors equal to 7. So knn equal to k neighbors classifier n underscore neighbors equal to 7. And then I have fitted the model. knn dot fit x underscore train y underscore train. Then it will be train the model, and now I have just getting the accuracy. So accuracy is 73%, nearly 73%, and you can also see that from this plot, I think. And then to actually and to measure how our model is correctly working or not, there are several metrics, you can say that. So there are confusion matrix, precision matrix, recall, and F1 score. So I just want to explain it in brief. For example, in confusion matrix, what we have done is if there are two classes, so the matrix size will be 2 cross 2. So you can see that for two classes 2 cross 2, and in x-axis there will be true classes, and this y-axis the predicted classes. So you can write here the one diabetic, and here is 0 or non-diabetic, and here like here also 1 and 0. So this one will say that how many points which are actually belongs to true classes, uh, which are actually belongs to diabetic, and my model is also predicting as diabetic, it means true positive. And it is means then now how many points which are actually belongs to class 0 or non-diabetic, and out of that how many of the and out of that my model is predicting how many of them as class 0. So it is called true negative. And the rest part is the false positive or false negative. And if I say in word, it will say that my originally this some points are belongs to class 1, but my model is predicting as class 0. Sorry, originally the points are belong to class 0, but my model is predicting is as class 1, so it is false positive, and likewise false negative. So for that you can calculate precision. Precision equal to TP means true positive divided by TP plus FP, and recall means TP plus FN, and the accuracy is the most, I think accuracy, and accuracy said, uh, out of all points how many points are correctly classified. So for that you have to take two summation TP plus TN, because these points are correctly classified, divided by all points. So TP plus TN divided by TP plus FP plus FN plus TN, and F1 score is the nothing but function of precision, sorry, TP and FP. So you can see that from this formula. So for to plot that, you can, there is a module called confusion matrix in scikit-learn matrix module. So just you have to uh, predict. So I want to take the x text value and predict it. So I have trained our model, so I have to see how my model is working, good or bad, using x underscore test. So you can just KNN dot predict x underscore test, and you can plot it confusion matrix, and it is taking two values, one is y underscore test and y underscore prediction. Because you can, I have already said that in x-axis there are original classes, and in y-axis the predicted classes. So y underscore test and y underscore prediction. Y underscore test for original classes, and y underscore prediction is how my model is predicting. So you can see that the arrays like that 165, 36, 47, 60. So it is saying that my model 165 points are such, like which are actually belongs to class 1, and my model is also predicting class 1. And 60 is saying that 60 points are there, like which are actually belongs to class 0, and my model is also predicting as class 0. That is the meaning. And 47 and 36 is false negatives and false positives respectively. So now you can also plot your classification report using sklearn. So you just have to import this classification underscore report uh, function, and you have to just pass the y test and y prediction like the confusion matrix, and you will see that precision, recall, F1 score, and support. So you can see that for zero classes the precision is something, recall is something, F1 score is something, and accuracy is given. And there is two more thing, which is macro average and weighted average. So what does it mean is, because in real world data set the data set is not balanced, means you can't say that there will be 50% data which are actually belongs to diabetic and 50% is non-diabetic. Actually in most cases this is unbalanced. So you can see that 80% or 90% are 90% of the points are belonging to the particular class, and rest are from different class. So for that you can give some weight to that, and this is what it is doing. If you take the weighted average it will give some weight, and if you give the macro average then it will give the same one, actually zero point 0.5. So you can see this formula here. So weighted average is giving, for example, I have I 99% of point are belonging to a certain class, and the less number one, and the rest one for belonging to class 1. So you can give some weightage to calculate the weighted average, and for macro average it is giving zero point 0.5 and zero point 0.5. So like that it is calculating this. So now there is a problem. So the problem is, so so can I ask the problem, what will be the problem in previous method which I have discussed, that just splitted train and test, and then feed the model using that and find the case, and then accuracy is, I am getting 73%. So so there is a problem. So what is the problem? So and it is similar, like why is cross validation needed? So it is a problem. There is a problem in previous method. The problem is, so in previous method, if you recall, that what we have done is we have taken the whole data set and then split it into train and test, and then using test we have computed the k values, for example k equal to 1 to 8, and then we have taken the k equal to 7 is the best one, and then calculated the accuracy is 73.05%. So can I ask this that question, that it is it ensured that the accuracy is 73.05% for the future data points also? It means that if tomorrow some patients came to me, and I just use this model, can the accuracy will be 73.05%? And the answer is not. It is not guarantee that always the accuracy is 73.05%. And because, and the reason is we have used the test set to determine the k, and also we have calculated the accuracy using the test. So my model has already seen the test data. That is why maybe it is giving 73.05%. So if tomorrow some new patient are coming and it may not work correctly, so for that, to resolve that problem, what we have to do is we have to split the data into three parts: train, cross validation, and test. So here the idea is we will compute k using train and cross validation, and we will not show our model the test set, and we will calculate the accuracy on test. So in that case, at the time of computing k, this model will not see the test set. So that is why it is important. So in this case, at the time of computing k, it is actually test is shown to our model. But in here we have created three parts: train, cross validation, and test. And now we will compute k using train and cross validation, and then I will determine the accuracy on test, which is called generalization accuracy. And this accuracy, you can say that this is the accuracy 73 or 74. It will be for the future data also, future unseen data also. So here the idea is, so for example, we have splitted the data into train 80% and test 20%. Okay. And in cross validation, what it is done at, for example, there is a concept called fourfold, fivefold, tenfold, like that. So if I say what is fourfold does, what does fourfold do? So it is doing that it will split the data into four parts: d1, d2, d3, d4, and each one will be 20% because my whole train is 80%. And now it will compute the best k. For that, first for k1 it will take first train d1, d2, d3, and for cross validation it will take d4 and calculate the accuracy, and it will shuffle this d1, d2, d3 between train and cross validation, and will calculate the accuracy for four times, and k equal to 1 will be there. So k equal to 1, you can see that train d1, d2, d3, and cross validation d4, calculate the accuracy a1. And next for k equal to 1, again d1, d2, now d4 here, d3 here, and calculate accuracy a2. And for k equal to 1, next d1, d3, d4, and now d2 is here, calculate the accuracy a3. And like that, you shuffle the d1, d2, d3, d4, calculate the accuracy, and average the accuracy. And like that, you have to do it for k equal to 1, k equal to 2, for k equal to like so on. So now this accuracy will be, I think, the generalization accuracy, and in which you can trust. This accuracy will be, I think, good. So for that, I have also implemented it. You can see that from scikit-learn matrix accuracy score. So in previous code, if you see that there are only this line was present only, x train underscore x test x y underscore train y underscore test, and then xy is splitted into 0.3 test size means 70% train and 30% test. And now what I have done is I have taken this 70% of train, 70% of x so you can see that whole data xy is splitted into train and test, and then I have taken this train data set, as I have said that train data set for again training and cross validation. So you can see that x underscore train y underscore train is taken, and it is splitted into training and cross validation. So now the train size will be 49% and cross validation 29%. So actually the sum is 70%. So first 70/30, and then 70 splitted into 49 and 21 train and cross validation. Now I want to compute k using this uh, training and cross validation. So I will not show the test data at the time of computing. So here the code is similar. So you can see that I have taken for I in range I 32. It means that I want to take the k value from 1 to 30 with two step size. So it will take 1, 3, 5, and the odd number of k's. So I have already said that odd number of k will help you to at the time of majority voting. So if the odd size, then it will be easy to take the majority number of votes. So next is code is straightforward. KNN, k nearest neighbor in n neighbors equal to I. So I will range from 1 to 30. Then I have fitted the model using x train and y train, and then you can see here and then you have uh, predicted the cross validation data. We have predicted using cross validation data, and we have plotted the several values of k and their cross validation accuracy. So from 1 to 30 you can see the output here, 1 to 29. So 30 minus 1, 29. So you can see that for I think k equal to 19, 74% is the accuracy. So now uh, I have computed k, and now I will train the model using k on training, on testing. So now I have fitted that x. So now I want to calculate the accuracy using test. So in previous method, uh, I have used the same data, training and testing data for computing k, and again the test data is used for computing the accuracy. But here we have uh, we have used the cross validation data to compute k, and then to compute the accuracy we have used the testing. So here you can see that x test is there, prediction using x test, and the accuracy score is measured. And now for test accuracy is for k equal to 19 is 73%. So here it is coincidence, you can say that 73% here also and there also, but in several real world problem this case will may not be same. So and I think this approach is better than the previous one. And in all sklearn also there is a grid search cross validation function. Here you can also mention the number of fold you want to use. For example, I have mentioned that in this example I have used four fold cross validation. So you can do 10 fold, 4, 8, 5 like that. So you can do that using this function called grid search cross validation. So you can do it, and the code will be straightforward like the previous one. So I think that's it, and if you have any doubt you can ask. Am I audible? Hello?
Yes, you are audible. Yes.
Yes, sir.